Hello, today we're going to be talking about how the muscle fibers actually contract. And I just wanted to start off kind of reviewing the sarcomere. Sarcomere is Z line to Z line. We have thin and thick filaments. The thin filaments is a combination of troponin, tropomyosin, and actin. And the thick filaments is going to be a myosin. The myosin, I don't know, kind of looks like a golf club, but the myosin head in particular is going to be very important in making the muscle move. And it's in a theory called the sliding filament theory. So muscle fiber contraction is a very complex interaction of molecules and organelles. Pretty much the thin and thick filaments, myosin and actin, bind together in a pulling action. Now they kind of slide past each other, shortening the muscle fiber as that myosin head kind of uses it as a propeller or a ratchet. So the sliding filament theory is when thin filaments slide past the thick ones, overlapping to a greater degree than during the relaxed period. The results are the contraction distance between the Z lines is reduced, I bands are shortened, H bands, H zones disappear, and the A bands are going to move closer together, but they don't change in length. So I'm going to show you all of this through a lot of different diagrams and animations. So you can see here how there's a sarcomere at rest and one that is contracted. And you can see how the thin filaments are going to flow over closer to that middle line in the H zone, kind of making the H zone disappear. So when muscles contract, the muscle fiber has a lot of ATP, and calcium is very low in the sarcoplasmic reticulum. So the myosin heads do not actually contract the actin receptors because of the presence of the tropomyosin troponin complex. Now, this is going to release acetylcholine, which is a neurotransmitter, by the neurons, which is going to cause the sarcoplasmic reticulum to release 5-calcium. This is going to cause the tropomyosin troponin complex to change the shape and move, allowing the myosin head to bind. Okay? And the energy from the ATP allows for that ratchet-like movement. Now, it's then going to have the muscle relax. And the muscle cell will relax when acetylcholine is destroyed by an enzyme. So the calcium will then move back to the sarcoplasmic reticulum. Now, more ATP is needed to release the myosin heads from the actin.